All right, logicians, what I want to talk about today is how you use an indirect truth table in order to determine whether or not an argument is valid or invalid. Now, what I've got set up here is an argument in the form of a truth table. So here's a premise, here's the second premise, and here's the conclusion. Now, when you're testing for validity, remember, here is the criteria for when an argument is valid. If it's valid, then all the premises are true and the conclusion is false. So when you're using an indirect truth table, what you want to do is you want to see if there is any possible truth values for which these premises will both turn out to be true and this conclusion will turn out to be false. Now, when we talk about the truth and the falsity of these different statements, what we have in mind is the truth value of the main operator that ranges over the whole compound statement. So in this case, this is the main operator, this horseshoe. In this case, it's the wedge. In this case, it's another horseshoe. And what we're trying to come up with is a scenario in which this turns out to be true, this turns out to be true, and this turns out to be false. So when you're working these indirect proofs, you want to ask yourself, what's the easiest way for me to do this? Okay? In other words, what we're going for is a false, a true, and a true. Now, with a horseshoe, there are 3 different ways in which a horseshoe can come out to be true, right? You can have true antecedent and true consequent. You can have false antecedent and true consequent. You can have false antecedent and false consequent. So that's 3 different scenarios we have to work through. That would be a big pain. With the wedge, there's also 3 different ways that the wedge can be true. You can have Q is true, but S is false. You can have Q is true and S is true. And you can have Q is false and S is true. Again, that's a big pain to work through all that. But when you come over to this one, here we've got a horseshoe. And there's only one way that a horseshoe can turn out to be false. Only one possibility to work through. The only way for a horseshoe to be false is if you have a true antecedent and a false consequent. So let's start there. What you want to do is figure out which of these truth values is going to have the fewest possibilities for you to work through, and you start there. Okay, so we know that if we're going to come up with a counterexample, and this is going to be false, then not Q has got to be true. And if not Q, if the negation is true, that means Q has got to be false. Because of course, negation just flips the truth value. So we can come back over here and be like, okay, in this possible scenario, Q is false. Now, there's only one way for a wedge to be false, and that is if both the disjuncts are false. If even one of them was true, the wedge would be true. So in this possible counterexample, S and P are both going to be false. Now what we want to do is take these truth values and we want to see, well, if we plug in these truth values, do the premises come out to be true? And if the answer is yes, they do, then we've shown this argument's not valid. But if they don't, then we've shown that the argument is valid. Okay, so let's start here. We know that Q is false, and we know that S is false. And that means that the wedge is false. Now, that tells me something really important, because if the antecedent of a horseshoe is false, then what do we know about the horseshoe? We know it's true. Anytime that the antecedent of a horseshoe of a conditional is false, then no matter what the consequent is, it's true. And then let's come over here, and we know that Q is false, and And so therefore not Q is true. Now, even though S is false, that's okay because if not Q, if one of the disjuncts is true, then this premise is true. Bingo. You know what we just got? We've just proven that this is not a valid argument because we've come up with a situation where this premise is true and this premise is true and this conclusion is false. So this argument is not valid. Now, there could be scenarios where you have to work through multiple possibilities and you've got different lines and you're trying to figure out is there any combination of truth values in which we get that, and so you could have multiple lines you have to work through. Furthermore, it could have come out that there's no possible way where this turns out false and all these are true. And in that case, you would have shown, no, it's a valid argument. One more thing I want you to notice, and that is, it doesn't matter whether R is true or false. Because we didn't even have to figure that out in order to come up with this truth value. And if you notice over here, whether R is true or false, because P is false, we know that this conjunct is going to come out to be false. And that's why it didn't really make any difference. So, all right, that's how you use a truth table to determine, an indirect truth table to determine validity or invalidity.